What's up everyone, it's Stack Lessons here. Welcome back to the channel. Today we're diving into Apache open source on Amazon Web Services, Spark, Flink, Kafka, Hive, Airflow, and Iceberg. Let's get into it. Picture this, your team just inherited a data platform running on premises, a Kafka cluster streaming events, a Spark job crunching the nightly batch, and an Airflow scheduler tying it all together. Your job is to move it to Amazon Web Services. Do you know which managed service each one maps to? By the end of this video, you will. Spark, Flink, Kafka, Hive, Airflow, Ranger, Cassandra, and Iceberg, 8 Apache projects, 8 Amazon Web Services, one clean mapping you can recall on demand. Here is the mindset shift for this entire topic. Nobody is asking you to tune a Spark shuffle partition or handwrite a Flink checkpoint configuration. The skill is recognition. If a colleague says their pipeline uses Flink, you should instantly know which Amazon Web Services console to open. See Apache Spark in an architecture, immediately think EMR or Glue. That is the whole skill. Recognition, not mastery. And once the mapping is internalized, the architecture decisions become clear. So why does Amazon Web Services offer all of these in the first place? Because running open source data infrastructure yourself is operationally brutal. Self-managed means on call at 3 in the morning when a Kafka broker dies, when Zookeeper needs an upgrade, or when partitions need rebalancing. A Spark cluster needs node provisioning, version management, and auto-scaling logic. The managed services exist so you stop doing all of that. Amazon Web Services runs the cluster, handles the patching, and hands you the endpoint. One mapping table covers all 8 projects, and we are about to walk through it. And here is the important part: they keep the original API intact. Existing clients still work, your Kafka producers run on MSK without changes, and your Airflow DEA-C01 run on MWAA unchanged. Here is the entire lesson on one slide, top to bottom. Spark runs on EMR and Glue. Flink runs on managed service for Apache Flink. Kafka runs on Amazon MSK. The Hive Metastore is replaced by the Glue data catalog. Airflow runs on Amazon MWAA. Cassandra runs on Amazon Keyspaces. Ranger integrates with EMR for fine-grained row and column access. And Iceberg is the open table format supported across S3 tables, Athena, EMR, and Glue. That is all 8 rows. If you remember nothing else from this video, remember this slide. We'll spend the rest of the lesson reinforcing each row, but this is the picture you want burned into memory. Let's start with Spark. Apache Spark is a distributed in-memory processing engine that handles batch, streaming, SQL, and machine learning workloads. On Amazon Web Services, it shows up in 2 places: EMR and Glue. And here is the thing many people miss: Glue uses Spark as its processing engine under the hood. PySpark is the primary API you'll see on Amazon Web Services, so when a question shows you PySpark code, the answer is almost always Glue or EMR. And as a small bonus fact, the EMR-optimized Spark runtime is up to 4.5 times faster than open-source Spark, while staying 100% API compatible. So when do you pick EMR versus Glue? Think of it as control versus convenience. EMR gives you a cluster, persistent or transient, that you control. You get the full Hadoop ecosystem: Spark, Hive, Flink, Presto, and you can tune Spark configs, the JVM, and instance types down to the metal. On the other side, Glue is serverless. No cluster to manage, just Spark with PySpark and the dynamic frame abstraction, plus a built-in catalog, crawlers, and job bookmarks. The rule of thumb the community uses: if you need to tune Spark configs, you want EMR. If you just want to move and transform data, you want Glue. Next up is Flink. Apache Flink is an open-source engine for unbounded data streams. designed for low latency and stateful computations like windowing, joins, and complex event processing. Its claim to fame is exactly one semantics, which we'll see in a moment. On Amazon Web Services, Flink runs on Amazon Managed Service for Apache Flink. You may also see this called Kinesis Data Analytics in older material. It's the same service, just renamed. The key distinction here is that Kinesis data streams transports events from producer to consumer, while Flink actually processes them with stateful logic. Straight from the Amazon Web Services documentation, by default, managed service for Apache Flink applications use exactly once semantics. Think of exactly once like a bank ATM that uses receipts and pending transaction logs. Even if the machine crashes mid-withdrawal, when it comes back online, it knows precisely which transactions completed and which to retry. You're never double-charged, never underpaid. So when a scenario mentions exactly once and streaming together, this service is almost certainly the answer. Now for Kafka. Apache Kafka is a distributed event streaming platform organized around topics, partitions, and brokers, with publish-subscribe semantics. On Amazon Web Services, Kafka runs on Amazon MSK, which stands for Managed Streaming for Apache Kafka. The key selling point here is that MSK runs the actual Apache Kafka, so it's 100% API compatible. Your existing Kafka clients, Kafka Connect connectors, and Kafka Streams apps all work unchanged. For authentication, MSK gives you 3 options: IAM, Mutual TLS, or SASL/SCRAM. And one subtle but important point, Kafka topic-level access control lists apply when you use TLS or SASL, but not when you use IAM. With IAM auth, you use IAM policies instead. Here is the decision rule that comes up regularly in architecture discussions. If the scenario mentions existing Kafka producers and consumers, or migrating from on-prem Kafka with minimal code changes, choose MSK. The whole point of MSK is to preserve the Kafka API, but if the team is building Amazon Web Services native streaming from scratch with no Kafka history, Kinesis is the simpler choice. The cue is always in the scenario wording. Look for the phrase existing Kafka, and the answer is MSK. Apache Hive has 2 parts: a query engine and a Metastore that holds schemas, table definitions, and partition info. On Amazon Web Services, the Hive query engine runs on EMR, but the more important piece is the Hive Metastore, which the Glue data catalog replaces. The Glue data catalog sits at the center, and every major engine reads from it. Athena queries it for serverless SQL. EMR Spark uses it as a drop-in Hive Metastore. Glue ETL writes curated tables into it. Redshift Spectrum joins external S3 data through it, and SageMaker reads it for feature discovery during model training. One catalog, many engines, all sharing the same source of truth. Think of it this way: the Parquet files are the books on the shelves in S3, and the catalog is the card index that tells every engine where to find them. Straight from the Amazon Web Services Glue documentation, the Glue data catalog is a fully managed Apache Hive Metastore compatible metadata repository. Here is what that compatibility unlocks in practice. A Glue ETL job writes a curated table into S3 and registers it in the catalog. An analyst then queries that exact same table from Athena, and an EMR Spark job reads it for a downstream feature pipeline. All 3 engines hitting one catalog, no schema duplication, no metadata drift. That is the payoff of building a drop-in Hive Metastore replacement. Now Airflow. Apache Airflow was originally built at AirMIB, and it became the de facto standard for workflow orchestration. Pipelines are defined as DEA-C directed acyclic graphs written in Python. Each node is a task, the arrows are dependencies, and there are no loops because water only flows downstream. On Amazon Web Services, Airflow runs on Amazon MWAA, which stands for Managed Workflows for Apache Airflow. The model is dead simple. You drop your DEA-C Python files into an S3 bucket, and MWAA handles the scheduler, web server, workers, and auto-scaling. MWAA fits naturally into Amazon Web Services data pipelines alongside services like step functions and Glue. The decision rule: if the scenario mentions existing Airflow DEA-Cs or a Python-rich pipeline, choose MWAA. Here is the orchestrator decision in one line. If you see the words DEA-C or Python or existing Airflow, choose MWAA. If you see Amazon Web Services native state machine or paper execution or fully serverless orchestration, choose step functions. One small caveat worth knowing: MWAA is not serverless in the traditional sense. You pay for the environment around the clock, while step functions truly bills per execution. Apache Ranger is an open-source framework for fine-grained, centralized authorization across the Hadoop ecosystem. It controls access at the database, table, column, and even row level, and supports column masking, primarily for Hive workloads on EMR. Think of Ranger as the bouncer at a private club with a detailed guest list. Alice can read the customer table, but only rows where region equals US, and she cannot see the email column. On Amazon Web Services, Ranger integrates directly with EMR with one operational caveat: you bring and manage the Ranger admin server yourself. So when a scenario describes fine-grained access on EMR and the organization already runs Ranger policies, that is your answer. We will cover the modern alternative in the next scene. Now let's talk about Apache Iceberg, because it deserves a moment of attention. Iceberg is an open table format that adds a CID transactions, schema evolution, time travel, and partition evolution on top of data files sitting in S3. Here is the analogy that makes it click. Raw parquet on S3 is like a pile of receipts in a shoebox. Iceberg is the same shoebox, plus a ledger that says receipts 1 through 47 are this month's expenses, 48 through 52 are voided, and as of yesterday, receipt 14 was edited. Same physical files, but suddenly you have database-like behavior. Iceberg was originally built at Netflix and is widely supported across Amazon Web Services including Athena, EMR, Glue, and S3 tables. Iceberg has 3 signature features you should recognize on site, and we'll walk through each one. The first is schema evolution. You can add, drop, rename, or reorder columns without rewriting any underlying files. The trick is that Iceberg references columns by field ID, not by name, so a rename is just a metadata update. Practitioners report renaming columns on multi-petabyte tables in seconds. Time travel is the second. Every write creates a new snapshot, so you can query the table as it existed yesterday at 3 p.m. It is like having Git history for your tables, which makes audit and rollback trivial. Partition evolution is the third, and this one is unique to Iceberg among the major table formats. You can change the partitioning scheme, say from daily to hourly, without rewriting existing data. All 3 are metadata-only operations on existing S3 files. Let's compare directly. With raw parquet on S3, the files themselves are the source of truth. Schema changes risk breaking old readers, there are no transactions or rollback, and repartitioning means rewriting the data. With Iceberg, you get a metadata layer over those same parquet files. Schema evolution works safely because columns are tracked by field ID. You get a CID snapshots and time travel for free. And partition evolution happens without rewriting a single byte. Same physical storage, completely different capabilities. Here is a capability of Iceberg that often gets overlooked. From the Amazon Web Services Analytics documentation, Iceberg supports a CID transactions, allowing multiple users and applications to concurrently read and write data without data conflicts or corruption. Think about what that means on S3. 2 Spark jobs writing to the same table at the same time, an analyst running a Trino query against it, and none of them see partial writes or torn reads. Transactional guarantees on object storage, that is the unlock Iceberg brings to the data lake. One more pairing. Apache Cassandra is a distributed wide-column NoSQL database that uses CQL, the Cassandra query language. On Amazon Web Services, the answer is Amazon Keyspaces, which is serverless and CQL compatible. Same drivers, no infrastructure to manage. Here is the trap to avoid. When a scenario mentions Cassandra or CQL, the answer is Keyspaces, not DynamoDB. Both are NoSQL databases, but they use different data models. Cassandra and Keyspaces are wide column, while DynamoDB uses a key value and document model with its own proprietary API. Keyspaces is purpose-built for migrating existing Cassandra apps with minimal changes, which is why it, and not DynamoDB, is the right fit when the question names Cassandra. 8 keywords, 8 services. Here is the decoder you'll use to read any scenario. PySpark code or Spark job, Glue or EMR exactly once combined with streaming managed service for Apache Flink. Existing Kafka producers or consumers, Amazon MSK Hive Metastore compatible, the Glue data catalog. Python DEA-C or existing Airflow, Amazon MWAA. Row or column level access on EMR, Apache Ranger. Cassandra or CQL workload, Amazon Keyspaces. In schema evolution or time travel on S3, Apache Iceberg. Read the architecture, match the keyword, pick the service. The rest of this video walks through each one in depth, so you'll know not just the mapping, but the why. Alright, let's see how well that stuck. Question 1. A company is migrating an on-premises Apache Kafka deployment to AWS. They want to keep their existing Kafka producers, consumers, and Kafka Connect connectors working with minimal code changes. Which service should they choose? Is it A, Amazon MSK, B, Amazon Kinesis data streams, C, Amazon Managed Service for Apache Flink, or D, Amazon SQS? Take a moment to think about it. The answer is A, Amazon MSK. MSK runs actual Apache Kafka under the hood, preserving 100% API compatibility. Existing Kafka clients, Connect connectors, and Streams apps work unchanged. Kinesis has its own SDK, which would require rewriting every client. Question 2. A data engineering team needs to perform real-time stream processing with stateful windowing and exactly once processing guarantees. Which AWS service is the best fit? Is it A, Amazon Managed Service for Apache Flink, B, Amazon Kinesis data streams, C, AWS Glue streaming ETL, or D, Amazon MSK? Take a moment. The answer is A, Managed Service for Apache Flink. The combination of stateful streaming and exactly once is the giveaway. Kinesis data streams only transports events. MSK is the Kafka transport layer. Flink is the actual processing engine, and exactly once is its default semantic. Question 3. A team operates a multi-petabyte data lake on S3 and needs to rename and reorder several columns in a wide table without rewriting any data files. Which approach should they use? Is it A, convert the files from Parquet to ORC and re-register them in the Glue data catalog? B, run a Glue ETL job to rewrite all files with the new schema? C, use S3 object lambda to transform column names on read? Or D, use Apache Iceberg as the table format which tracks columns by field ID? Take a moment. The answer is D, Apache Iceberg. Iceberg references columns by field ID, not by name, so renames and reorders are pure metadata operations. The other approaches would all require rewriting petabytes of data. This is exactly the use case schema evolution was designed for. Question 4. A team has an existing collection of Apache Airflow DAGs written in Python that they want to run on AWS with minimal refactoring. Which orchestration service should they choose? Is it A, AWS Step Function Standard, B, Amazon MWAA, AWS Glue Workflows, or D, Amazon Event Bridge Scheduler? Take a moment to think. The answer is B, Amazon MWAA. MWAA runs actual Apache Airflow, so existing Python DAGs work unchanged. Step functions would require rewriting every DEA-C as a state machine. Glue workflows are glue only, and Event Bridge Scheduler handles scheduling, not full orchestration. Question 5. A company is migrating an existing Apache Cassandra application to AWS and wants to keep using CQL with minimal code changes. Which service should they choose? Is it A, Amazon DynamoDB, B, Amazon Keyspaces, C, Amazon DocumentDB, or D, Amazon Aurora PostgreSQL? Take a moment. The answer is B, Amazon Keyspaces. Keyspaces is the CQL-compatible serverless equivalent of Cassandra on AWS, so existing drivers and queries work unchanged. DynamoDB is also a NoSQL database, but it uses a key value and document model with its own proprietary API. DocumentDB is for MongoDB workloads. And Aurora PostgreSQL is a relational database. Here is the full table one more time. Spark maps to EMR or Glue, Flink maps to Managed Service for Apache Flink. Kafka maps to MSK, the Hive Metastore maps to the Glue data catalog. Airflow maps to MWAA, Cassandra maps to Keyspaces. Ranger handles fine-grained row and column access on EMR, and Iceberg brings schema evolution, time travel, and ACID transactions to S3. That is the entire mapping. Next time someone hands you a data architecture with Apache names scattered across it, you are the person in the room who knows exactly which Amazon Web Services service to reach for before anyone else does. That is the real outcome, the confidence to translate any open source data stack into its managed Amazon Web Services equivalent on the spot. And that's a wrap on Apache open source on Amazon Web Services, Spark, Flink, Kafka, Hive, Airflow, and Iceberg. If this helped you out, smash that like button and subscribe for more. See you in the next one.